Hello everyone, my name is Jim Garrity. I have a small milling project to do today. In this video I'm going to show you some basic milling techniques using a manual milling machine. Ta-da! In fact, 2 milling machines, but more on that a little later. Come, join me at my desk at the back of the workshop where some really well-wrapped material has just arrived. Just had a delivery, here it is here, and this contains the material for the next project. Whoa, I'm in. That was hard work. Some time ago, I made 21 of these. This is a Windjammer. It's a furry cover that goes over a microphone and it cuts down on wind noise. Inside this there's a foam dome, and then that's supported by a series of spring steel wires on a supporting disc. And this is a subject in its own video, or its own set of videos, where I explain how I make all that. Now the chap that I made that for, he's requested a mount to hold that Windjammer at a particular angle. Now he's made one out of plastic on his 3D printer, but unfortunately it's not strong enough, so he's asked me to make 6 of these out of aluminium, and that's what these bars are going to do. This is the raw material to make 6 mounts for the Windjammers. Now I haven't got a drawing for this mount, and I've been told all the dimensions are present on here, and this surface has got to be at 30 degrees. So really that's all I need. So I think the first thing I'm going to do is make a sketch of this so I know what I'm doing. I've made a drawing now of the part that we've got to manufacture, which is shown here, but let's just have a look at the original 3D printed mount. Now you'll see that it's 30 millimeters across this face and 20 millimeters across here. Now I can't get hold of 30 by 20 aluminium bar, but what I can get is 30 by 25. Now if I leave it at 25, then that means this slope surface, instead of having a step here, will come up to a sharp point. So it'll be increasing the surface that the Windjammer sits against, which will increase its stability. So what I'm going to do is make this with a sharp knife edge along here. If the customer doesn't like it, then I can bolt it down to the fixture later and take that 5 millimeters off. But I'm thinking that it will add to the stability, so it's got to be a good thing. You'll see that there's 5 holes in this 3D mount. Now we'll look at these 3 first. 1, 2, 3, and you notice one in the center is a counterbored hole. It has a flat bottom, and a socket head screw will go in there, M5, and then hold this down to the frame, and the same screw will be put in at each end as well. Now on the 3D model we've got these scallops taken out at each end. On the aluminium block that I make, I'm not going to have these scallops. This slope surface will come along to a flat end at both ends. So there will be 3 counterbored holes, which will take the screws in this plane down and attach this to the mount that's underneath it. The other 2 holes are here. They are M5 inserts at the moment. On the one that I make, they're going to be M5 tapped holes, and they're perpendicular to this surface here, so they're going in like this on both sides, and they will accept the 2 screws that go through the Windjammer and then hold the Windjammer onto this, where the other 3 will hold this onto the support frame. We're going to be machining the 3 counterbored holes to start off with, and they are in the center of this face. And first of all we need to mark it out, so I have a marker here. In fact, before I do that, just in case there's any oil on there, let's excuse me, wipe the face. Go on with the marker. Now it doesn't have to be too accurate, because the accuracy is going to come from the milling machine once you get it on there. Now we know that it's in the center of this face. This material is 30 millimeters thick, so 30 millimeters across this face here. So if we go down to here, we zero the height gauge, we can check the height of the material, and that's 29.88, so near enough 30. We want to come up 15 millimeters from the surface plate. 15, 10, 12, 13, 14, 15 millimeters. Push the lock on, and now we want to scribe a line along this face. Just like that. So now we have a line along there. Right, we now need to mark one end as the datum face. So that's going to be our datum face at this end. I'll bring that up to the square here. Now the first hole is going to be 10 millimeters up from the datum face. So we'll take the lock off down to the surface plate, and then up 10 millimeters. 10 millimeters on with the lock, and hold the material square against the base plate, the surface table, and then mark the line. We now go up. We've got 90 plus 10, which is 100. 50, 70, 80, 90, 100. 100.02 will be close enough, and we mark the line on here. And the next one is another 90 up, so that's going to read 190. 90.01. Hold that square against the square at the back, and mark the position of the hole. So now we have 3 scratches, 1, 2, 3. And we can go across to the milling machine now, where this is going to be held in the vise, and we can center drill these positions. We're now across at the milling machine. I've put our job in the vise, and I've removed the milling chuck and replaced it with a drilling chuck. Let me bring you a little bit closer, then you can see what's happening. You remember that we have 3 holes to drill along this face. I've eyed up the center drill on this first hole, and you can do that quite accurately, as accurate as we need on this job anyway. But then the next hole is going to be 90 millimeters down, and then the next hole another 90 millimeters, and that traverse is going to be controlled by the milling machine. So the distance between the holes is going to be very accurate, and we may be off by a few tenths here, but that doesn't really matter. So the first thing we do is just center drill the 3 locations. So I'll just turn the motor on now. So I'm bringing the table up, and I can feel the drill just touching. So that's the first one, and that's all we need just to get a centre there. And now we advance the table 90 millimeters. We're now looking at the control wheel for the bed. The bed moves in this direction, and that's called the X-axis. Hand wheels are important things. They can be used to control lathes as well as milling machines and a whole host of other machinery. Let's take a moment to have a look at them. As I said before, turn the hand wheel 1 revolution and the bed of the mill will move 5 millimeters. You will notice here a scale wheel. It is attached to the hand wheel, so we'll turn with it. This wheel displays how far the bed has moved, and you read the distance from the scale against the read line just here. The read line doesn't move. The scale you see here displays the distance. From this point to here is 0.2 of a millimetre. Each of the small divisions on the scale just here is 0.02 of a millimetre. That's just under 1/1000th of an inch, or 0.00078 to be exact. One of the other things about the scale wheels is that although they're connected to the hand wheels, they can also be rotated independently of them through a friction joint. What this means is once you've set the bed at a precise position, you can then rotate and zero the scale wheels without affecting the position of the hand wheels or the bed. Now this is really useful. There are normally 3 basic hand wheels on a milling machine. They control the X, Y and Z axis movements of the bed. Each have their own scale wheels, and this enables you to move the bed quite accurately in all directions. Sometimes the bed of a milling machine has a hand wheel at each end to control the X-axis, but normally only one has a scale wheel. So 5, 10, 15, 20, 75, 80, 85, and now 90 is, where's it gone? Where's it gone? There it is. Just there. And that's moved the bed 90 millimeters in that direction. Bring the table up and I can see that the center drill is right over that line, and now we can drill the second hole. Well, we're not going to drill the hole, we're going to mark the hole with the center drill. Just like that. Come down and advance the bed another 90 millimeters. And again I can see that the center drill is right over our cross. We come up and just center drill that third hole just there. So now what I need to do is change the drill to a 5.2 millimeter drill, which is the clearance for N5. Like that. And now we turn the motor on and we start drilling. And we are through. Come down so the drill is out of our job, which it is there, and now advance the bed 90 millimeters. So our drill should go straight into the center dot, which it does. And that's the second hole drilled, and that's the third hole drilled. Right, the next thing I need to do is take out the drilling chuck and put in the milling chuck. So we're now looking at the front of the milling machine. Now the handle that moved the table in X direction is over here. This handle in the middle is the handle that moves the table back and forth, and that's the Y axis. And when you want to bring it up and down, that's in Z, and that's when you use this handle at the end here. So if I turn it anti-clockwise, the table comes down. Turn it clockwise, the table comes up. Each of these handles have scales on here, so you can see how many millimeters, in this case because they have millimeter scales, you've moved the table. I've placed the milling cutter chuck in the mill now, and it has a milling cutter in there with a flat bottom. This milling cutter produces a flat bottom hole, so you can use it for counter boring. So now we're going to turn it on, and we come down and we just touch the surface, and then we plunge down 19 millimeters. With this particular mill, I can't bring the cutter down to drill a hole. I've got to bring the whole bed of the machine up, and what I'm going to do is just move the handle now, the handle that I showed you, move the milling machining the Z axis until the cutter just starts to touch the surface. And when that happens, I will zero the scale that's around the handle that I'm turning. And I can see it's just started to touch the surface there. So I now set the wheel to 0, and now I can carry on turning the wheel clockwise, which will bring the table up, and now you see the flat bottom hole is starting to form. Now we've got to go down 19 millimeters. Each rotation of this wheel increases the height of the table 2.5 millimeters. So we've got to go around 7 times plus 1.5 millimeters to make our 19 millimeters. I've now gone down 7 full turns, and I'm just checking it again. We've got 1.5 mil left to do. So I've just come to the top of the hole, and I now turn the handle 7 times. In fact, what I'm going to do is put a little bit of oil on first to stop any chatter. So 1, 2, 6. Take it easy. I don't want to bottom the cutter out too hard. So we come up to 7, and now we're cutting. That's 0.4, that's 0.5 mil, 1 millimeter and a half. And we come back out the hole. So we've just machined a flat bottom hole, a counterbore, 16mm deep. We now have to move the bed in that direction, 90mm, to get over this centre hole. Well, once you've seen one hole counterbored, all the others look pretty similar. I've heard people have actually thrown themselves off of tall buildings rather than watch another hole be counterbored. Well, with your well-being in mind, once that first hole was machined, I turned the camera off. We're now at the bench drill. We have the 3 burrs to take off from the underside of the piece of metal we've just counterbored. Countersink in the drill, turn the drill on, and get rid of the burr. And where are we now? We have our 3 counterbored holes in this surface here, and if we look at the 3D model, you can see that the counterbores line up, which is good. 1, 2, 3. So the next thing we need to do is this slope here. Now that's a slope at 30 degrees, and it's got to be put onto this face here. Now we're going to mill this on. First of all, I'm going to show you the Marlow, the milling machine behind me here, and because this is a traditional milling machine, and I will show you how we can set it up to mill this slope. So here's our 3D model. Now we've got to hold our piece of material such that we can cut this face at an angle. Now the head on this milling machine does actually adjust, and you can adjust it sideways up to 30 degrees. I think it is. Yep, 30 degrees in each direction, which is lucky because that's our angle. The problem we have is in Y axis it only just moves 200mm. So that means that we can't hold this in the vise. Well, first thing is it doesn't fit in the vise in this direction. The vise just won't open up enough. So we really need to hold it in the vise in that direction if we're going to use the vise, or move the vise around. But you can see that there's not much meat left once that's clamped in the vise, and we don't want the cutter to hit the vise. So it'd be handy if we could bolt this to something, and then whatever we bolt it to, we clamp that on the milling machine. So that's what we're going to look at now. Now here's a possible way we could hold our piece of metal on this milling machine. It would involve this vise going around 90 degrees so the jaws come together here. I've got a piece of scrap aluminium here. It was left over from a CNC machine and thrown in the bin, so I managed to grab hold of this. I've drilled 3 holes along here and tapped them M5, and they're on the same pitch as our mount here. So I can screw this mount onto this lump of aluminium. I can then hold this piece of aluminium in this vise when it's round at 90 degrees, crank the head over 30 degrees. Let me just get the 3D representation. So if we put this here, so you can see that we can now move this head over 30 degrees and then machine this face here. However, I've checked the Y-axis throw on this machine, and it's exactly 200mm, and we need to cut 200mm. So it's all a bit close, and it could be a bit of a struggle. But that's a good way of holding it on this machine. However, we may have another way. Ta-da! A second milling machine. The first mill we were looking at, that's a Marlow A3 machine, marketed by Dronsfield. There's a good English name. This second mill is an Alexandra Master Toolmaker. It was made in the 1950s. This machine has got far more functionality than the Marlow. In fact, this will be my main milling machine once I get it finished off. Now I bought this a couple of years ago. There were bearings in the gearbox that needed changing. I've been all through that, took the whole lot apart, put it back together again to make sure it works, and it needs to come apart now to be painted. However, I've never used it for cutting metal. So when we have this job come along, I thought, oh, this could be it. This could be the first time we use it, and that's what I want to do. I want to cut the piece of metal, our mount here, on the table. Now you see this table is different to the Marlow because it tilts. You can tilt it in this direction, but you can also tilt it longitudinally as well, and it swivels. So you can get your job to all sorts of different angles, which is one of the good things about this mill. Now if we get this lump of aluminium, we can put that now nicely onto this plate and clamp it in position, the part that we need to cut at 30 degrees, that can be bolted to it through our 3 countersunk holes here, and we can run the cutter along here without having to adjust the head at all. So that's what I want to do. I will bring you closer so you can see the setup. So here we are, all nice and close, and you can see what's happening. This is the table, which is put somewhere near 30 degrees, but that's what we've got to set now. Now, clamped to the table is this block. Now, this block is a ground block, and it's a 30-degree block, and I've clamped it to the table using these 2 clamps here, but they're only finger tight, because it doesn't need to be very tight at all. Now, this miller machine is slightly different to the Marlowe, which is a 3A and not an A3 model, because the bed, when it moves in Y direction, this way, backwards and forwards, it doesn't use a handle down there. In fact, this bed can't move in that direction. What actually happens is there's another handle on the head, and when I turn that handle, the head goes backwards and forwards, and that's the Y axis adjustment. Now, because I want this at 30 degrees, and that block is a 30-degree block, what I want to do is adjust this table so that is parallel with the travel of the head. Now I can measure the distance between the head and this block with this here. This is a Dti gauge, a dial test indicator. Now let me adjust the camera angle and then you'll be able to see what I'm seeing. We're now looking down on top of the Dti gauge. The measuring post is underneath, so as the table is lifted, this surface will touch the measuring post, and as that measuring post is lifted, the clock will indicate how far it's been lifted. Now, the marks on the scale, each of the small marks is 1/1000th of an inch. So where it says 10, that's 10 thou, 20, 30, and so on. The maximum movement we have on this clock is 2 rotations. And you need to be careful of that because you don't want to bind it out, or you can get yourself in all sorts of trouble. So what I'm going to do now is bring the table up until it just touches, till the measuring point on the clock just touches this surface here. And it should start to lift, and you'll notice that the clock goes clockwise. Now it started here, and we've got 2 turns. So what we're going to do is take it around until around about here where the 0 is, just there. Now when I bring the head in this direction, it's going to measure the distance between where the head is set and this surface here. Because this surface is an angle, if it's not exactly 30 degrees, then this will vary in height and the clock will read it. So if we bring it forward, it's going clockwise, and it shows we've got 6 thou there, and as we come back this way it goes back to 0. I don't want to go too far because we'll bump into there. So you can see that that is clockwise. So at the moment the table is too high at the front, so we adjust that with a mallet. I have a leather mallet, and here's the end here. So I will tap the front of the table. Now it's held together and it's locked by bolts, but I've loosened the bolts off and just tightened them up slightly, and to retain the bed, but I can adjust it just by tapping it. So I will now 0 out the meter there and take this back. So that's gone down 5 thou. So we still need to bring it down at the front. So I will tap it a little bit more. I'll increase the table height to bring that back to 0, because that gives us a nice indication of where we are, and come forward. And it's still high, but it's gone up 1.5 thou. So it's 1.5 thou high at the front, so I need to tap it, but just a little bit now. And we're all set up. You can see that the DTI gauge is reading 0 there, and when I bring it to the front of this surface, it's still reading 0, which is great. I've also tightened up the table bolt so I know that it's now locked in that position. So the head will move in and out like this. So if we put in a cutter, it will cut in this plane, which is exactly 30 degrees from the surface of the table. So if we put anything on the surface of the table and machine it with a cutter in here, it will cut the thing that's on the table at 30 degrees. And that's exactly what we want for our mounts. I'm feeling quite excited. I've never cut any metal on this machine. All I've ever done to it is take things apart, fix things and put it back together again. Now I've checked all the oils, I've been running the motor, and I've just warmed the bearings up, so I'm quite happy that it's all working. I'm also finding little things which still need doing, like there should be a bolt here holding the head on. I have a bolt on this side, but there isn't one on this side, so I've got a little clamp on there holding it together. We're not going to be taking any really deep cut, so that's no problem. I've got a 3/4 of an inch cutter in the chuck here, 0.75 of an inch. We're going into aluminium. I've set the speed at 750 RPM. The plate has been clamped down to the table, and this is our mount that we're going to be machining, and you see that there's another piece under here. Now that piece of metal, what I did was set this up so it was running true, screwed it down, then once that was set I then put this piece, this parallel against it and clamped that in place. So now when I take this mount off and put the next one on, we'll be able to get it in the right place against this parallel, and then that will stop any inaccuracies coming through the clearance hole for the M5 screws here. So now this machine is 3-phase, and in the workshop I've got a 3-phase rotary converter. So the first noise you hear will be the rotary converter turning on, and then I'll be turning the motor on for the mill itself, and then we start attacking this side, and we'll keep machining backwards and forwards until this level here, the flat level, becomes 6 millimeters up from that edge, and that's the depth that we've got to stop at. Once we've cut this one and I'm happy with it, I'll then set the level on the height, the height wheel, and then all the others will be cut to the same depth. I'll turn the rotary converter on first. That's producing the 3-phase, and now I've got the switch on the side of the miller machine. I'll switch that on. Right, and it's now time for that very first cut. Seems to be working quite nicely. I'm now taking the second cut, all looking very nice. I think it's going to take a long time though to cut all of these 6 mounts. This is now the first cut across the front. I've taken several cuts across the back. The cutter isn't wide enough to go across the whole of the width of the cut here, so I've got to do it in 2 bits. So the rear of the mount has been cut all the way across, and now I'm doing the front. Once I get this one done, I'll then get back onto the rear and drop down and take more off there. But the machine seems to be working quite well. The cutter's cutting nicely, and everything's going rather hunky-dory. I'm very pleased. And that's it. This surface here at 30 degrees is cut full length across there, and it's 6 millimeters from this edge here down to the mounting plate at the bottom. So this one is now finished. That's 1 down and 5 to go. So what I need to do now is take the 3 M5 socket head screws out, take this off, put the next one back on, align it with this parallel which will stay on the jig, and then screw those 3 screws up holding the mount in place. Once they're tight, I can then start machining the second one. And our 6 mounts have all been machined at 30 degrees on this face, as you can see here, and they're all looking pretty good. The next job is to drill and tap 2 holes here. These holes is where the microphone is going to be mounted. The thread that we need in there is M5, so we need to drill through with a 4.2mm drill in the 2 positions. You can see I've put some marking ink on here and also scratched some lines, but that's only with a rule and a scriber, and it's just to give me a little bit of confidence I'm in the right place when I put it onto the milling machine. So the next thing we've got to do is put this back onto the fixture plate. We're going to line up on the edge of the job and use a centre drill to just dot both of these holes to make sure we get them in the right place. The distance between them is going to be controlled by the x-axis of the milling machine, so that's going to be really accurate. And here we are back on the Alex milling machine. I've put a ER20 chuck in the 1/2-inch collet. This is a U2 collet in the head of the machine, so that's now holding a ER20 collet, and that ER20 collet is holding the centre drill. Now what I'm going to be doing next, I know that I'm 90 degrees to this surface because this is the fixture plate that this was machined on, so I know that we're at the correct angle. I will eye up the centre of the centre drill with this edge and then bring it in the appropriate distance. It's 37.5mm, but I've got to now work that out in English because the control wheels on this Alex, it's all in English, so it's all imperial. The distance to the first hole is 37.5mm. Now I've worked that out into imperial, which is 1.476. To get to 1.476 using the x-axis wheel, I've got to turn the wheel 11 turns, so 11 complete turns plus 101 thou. So I've got the centre drill in line with the edge of the mount. I'm now going to zero the scale wheel. Now you see there's 2 discs here. The scale wheel is this one with all the numbers on. The disc here is a part of the bed, and that has our read line on. The handle, which is here, is also known as a wheel. That at the moment is attached to the scale wheel, so if I move the handle then the scale wheel will move. I can't move it at the moment because our drill is over the edge of the job, but what I can do is zero this scale wheel. Now the scale wheels on some of the wheels are held there with a friction joint, and all you've got to do is just push them and then they will skid. On this particular mill it's not like that. It's clamped in position by this wheel here. This is a clamp wheel. Now I want to loosen this. I need to unscrew the wheel, and I'm hanging on to the handle here so it doesn't move. So I've undone the wheel. I can now spin the scale wheel, and I'll spin it round until the zero line matches up with the read line, which is just there. I now do this up. You've got to be careful because I don't want to move the wheel, and let's get it back to where it was, just there. So the wheel is now ready to go. I now need to advance the x-axis 11 turns, then 101 thou. So we go 1, 2, 3, 8, 9, 10, and that's coming up to 11 as the 0 comes up to that read line. So that's 11, and now 101 thou. So it goes 10, 20, 30, 40, 50, 60, 70, 80, 90. There's the 100 line, and 100, and so it's 1, 2, 3, and each one of those lines is 1/1000th of an inch. So 101 is just there. So that is now in the correct position to drill the first hole. Now if I'm in the right position, then our centre drill should be over the line that I scratched, which it is. So we can turn the motor on and drill the hole. Now this milling machine has got a thing called a quill, which means this whole chuck assembly can come down on the head. If I pull this handle here, you see it goes up and down. The other machine, the Marlowe, doesn't have that. That hasn't got a quill facility, but this one has. So that's how I'm going to be drilling the hole. First I've got to turn on the 3-phase converter and then the motor of the mill. And now we drill the centre. Now that's the centre dot put in. Let me just turn the converter off. Right, the next thing to do is lower the bed down. I'll take out the centre drill, put in the 4.2 drill, and then drill through this into the fixture plate, and that will ensure that that drill is in the right position. I'll then put the centre drill back in, advance the table that direction. I need to go 125 millimeters to get it in the right place. Because this is imperial, that works out at 39 turns plus 46 thou, and that will get the centre drill over this next cross. I'll then dot it with the centre drill, lower the table, change it over to a 4.2 drill, and drill through with that. And that should get everything nice and drilled. And we have the 4.2 millimeter drill in the chuck, and we're just about to drill that hole on the left hand side there. Now we've got to put the machine onto a higher speed, so it's quite noisy, and I'll be turning that on now. And we can now start drilling the hole. I'm bringing it down on the quill, and you can see that it drills quite nicely. And that's it, we are through. Turn the machine off. And that's the hole drilled. The hole has been drilled 4.2 millimeters all the way through. I've put the M5 tap in the tap wrench, and I've taken out the drill and replaced it with a centre. Unfortunately, it's not a spring-loaded centre, so as I tap the hole and the tap starts going down, I'm going to have to increase the bed height to keep the centre engaged with the top of the tap. I've already put cutting fluid on the tap, so I can now start tapping this down. See, straight away it becomes loose, so I now need to bring up the bed just like that and carry on tapping. I've taken the mount off the fixture plate now. I couldn't tap all the way through the hole because the hole in the fixture plate wasn't deep enough. So now it's off. I've put the tap back in. There's some more cutting fluid on there, so I can now tap the last 5 millimeters or so of hole and make sure that it goes all the way through. And we are done. I have 3 of the units here. The rest are on the bench over there. The M5 holes have been drilled and cleaned out, all the ends deburred. Here we have 2 screws going in quite nicely. Counterbores are done on all of them. Everything is made to the right size. What more could you want? Well, I hope you enjoyed getting down and dirty with the milling machines today. I'm really pleased that the Alexandra Master Toolmaker worked, and I'm even pleaseder that nothing fell off it. Could you do a project like this? Of course you can. And with that, this video is at an end. Take care everyone, and I'll see you next time. Could you do something like this? Of course you can.